Welcome back to the Gliderfly project. In this video, I'll show you how we will compile all the CSV files of the data we've collected using your cell phone and the MATLAB Mobile App. So by now, again, you've converted it, you've extracted the data out of your cell phone, and now we're just trying to start getting it ready to plot. So go into your Google Drive. You should have four CSV files: position, orientation, angular velocity, and acceleration. I've started to open three of them. I'll open the last one. You simply double click and say open with Google Sheets, and it will convert or insert the comma separated variables into a sheet format. And what you want to do now is actually go in and add the units for each one. If you don't know what the units are, uh, check on your phone. It tells you, but for latitude and longitude, they're both in degrees. So I will type that in here. Altitude is in meters. Speed is in meters per second. One quick note, this is ground speed, not indicated airspeed. There is a difference. We'll talk about later. Of course, is degrees. We will not be using that, but the final one is accuracy of altitude, which is in meters. It just tells you how accurate your reading is. So now that you've inputted all the sensors units, because the number is useless unless you know what you're referring to, make sure you do that for orientation, angular velocities, and accelerations. Now, all of these sensors are in an axis, a coordinate system of XYZ in 3D. There's a separate video you need to watch if you haven't yet to refresh yourself of what that coordinate system is in reference to your cell phone, because it will give you an idea of what is my pitch, what is my roll, my yaw, and so on. So you need to really understand that. So again, acceleration, it's meters per second squared. Angular velocity is the displacement over time, so it's meters per second. And orientation is a displacement, so in degrees. So how do I compile them all? Well, as you've seen here, I've started to compile the accelerations and angular velocity into my orientation sheet. So I'm going to drop in my position stuff. So I'll click down here, say make a copy to an existing spreadsheet, and I will choose the orientation one. So I'll go through the folders, 2024, glider, data, whatever day you are in. And here's my flight one and my name. And I'll select my orientation, click insert. As that's happening, I will probably close my other Excel sheets as I don't need them. Again, they automatically save. You'll see it, it's here in the bottom. I'm just gonna drag it to the beginning and I'm gonna rename it, make a shorter name. Again, it's a position file and I already know it's my data. And now I'm gonna make a copy before we start messing with it in case we make a mistake. So I'm gonna make a copy of the data and I'm just gonna label it again, my flight number and my name, so I know it's mine. But now we have all the information we've collected from our cell phones, from all the sensors, in one Excel file or one Google Sheet file, and we can start converting units to making it more meaningful to you. Meaning, you might not really understand what a meter is, but you probably know what feet and miles are, because those are the units that we tend to use here in the US. So before we do that, one quick thing. So if you recall, we were sampling at 10 samples per second. So that's 10 readings per second. But for position, if you look at here, you have hours, minutes, seconds. You'll see the seconds are actually changing by increments of 1. So for position information, you're actually recording only at 1 sample per second. We couldn't change that. The other sensors, if you start looking at the seconds, you have 10 identical timestamps, which makes sense because we're sampling 10 samples per second. For a specific timestamp, you should have 10 readings. Now, again, that increment should be pretty much 1138, 56 decimal 0, then decimal 1, 2, 3, because again, it's a sample every 10 seconds. That's an increment of 0.1 seconds. The data set I'm using here is actually from 2019, some time ago, but it will get the work done for what I need to show you. So again, let's start with our position. So altitude is in meters. I actually want to convert it in feet. So I'm going to create a new column here, call it altitude, and say it's in feet. Now to convert, we need to know how many feet are in a meter. It's about 3 point something. If you don't know, just say, 1 meter to feet, or how many feet in a meter. So 1 meter has 3.28. We're going to round it and say 81. So that basically means you'll take your column of your altitude in meters and you're going to multiply it by that number, 3.281 feet. So again, since every single one, and I'll say yes here to convert all the data. Since every meter is 3 feet, then I should be multiplying those meters by how many feet are in a meter. So now we've converted it into the total number of feet. Now, if we want to get the speed, which is currently in meters per second, to something more meaningful to us, let's say in miles per hour, then now that I know in feet, then I can convert that to miles per hour, or I can use my meters to convert it into miles per hour. So in terms of, that would be kind of your change in altitude over time. For ground speed, that's a little bit different, but I'm trying to get you to that mentality of why are we switching units? Because again, for speed, it makes more sense in, at least to us, probably in miles per hour versus meters per second. So we'll start converting that. So we've done it for altitude. And a quick way to check if it makes sense what that number is, Google what the altitude is at the current location you're at when you were recording the data. And if it's around that range, then it's accurate. Meaning, in this case, I was probably 4,000 and some change above the sea level in terms of altitude. So it makes sense to me. Now, I'm going to convert my speed, my ground speed, into miles per hour. So how do I do that? Well, I would have to first convert the distance in meters to miles. I could do incremental, meaning from, again, meters to feet, and then I know how many feet are in a mile. Or I could just go from, hey, how many meters are in 1 mile? So I'm just going to try and jump through that. So I'm going to say, here's my speed. And I'm going to do it in miles, mi per second first. We'll convert it one unit at a time. So now I need to know, hey, how many miles are how many meters are in 1 mile? So I'll change it here to a mile. We'll look at that. There's 5,280 feet exactly. In terms of meters, there's 1609.34. So I have an idea. Let's first convert it into feet to continue kind of going that process of thinking. So in 1 mile, there's 5,280 feet. So if I actually go back here and let's change this instead from meters to feet per second first. So again, if you're converting the meters to feet, then if my speed is 1 meter per second, then that means my speed is actually 3.281 feet per second. So again, I'm going to be multiplying what my speed is by the 3.281 feet. And now those numbers should be converted into what my speed is in feet per second. But now I want to actually insert a new column. To my right. And now I want to convert that feet per second into miles per second. Again, I'm taking baby steps to get it to the miles per hour. So if this is now my speed in miles per hour, per second still. So if we know there is 5,280 feet in 1 mile, and this is in feet per second, to get it to miles, well, that would mean if my speed was 5,280 feet per second, that would be identical to 1 mile per second. So in this case, we're actually going to divide the column I by the 5,280 feet to get it into miles per hour. Again, because there's 5,280 feet in 1 mile. So I'll take this column and I'll divide it by 5,280 feet. And if I convert that, now we are in miles per second. Again, 5,280. So now, how do you convert seconds into hours to get into miles per hour? Well, let's add another column to the right. And now this is going to be in speed, miles per hour. So that is MI divided by HR, miles per hour, or how we're more used to it, miles per hour, MPH. So there is 60 seconds in 1 minute. So actually, let me take another baby step. So instead of jumping right into hours, I'm going to say miles per minute. So if I wanted to convert my miles in seconds to miles per hour per minute, there's 60 seconds in 1 minute. Now, traditionally, if the unit of time here was on the top, on the numerator instead of the miles, then we would be saying, okay, well, 1 minute is equal to 60 seconds. So if you knew you had 60 seconds to get it to a minute, you divide it by 60. In this case, the unit conversion that we need, we have to get it on the denominator. So in order to do that, if you think about it, you'll have 1 divided 1 minute. Let me think about this. Should I show you on the board or show you in the air? So if I have in seconds and I want to get rid of that, what I'm actually going to do in this case, it's multiplied by 60 seconds to get it into minutes. And then I'll show you why. So let me get my little paint tool here since I don't have my little whiteboard. But if you were to think about it, and I will draw it for you. If you have 1 second and you wanted to convert it into a minute, then that would be 1 minute has 60 seconds. So what we're doing here is we're converting from seconds to minutes, but in order to do that, we have to get rid of that second unit measurement. So this is just telling us at the end that 1/60th of a minute is identical to pretty much 1 second. Which makes sense, because if you had 60 seconds, that would be equal to 1 minute, right? So if you had 60 seconds and you divide that by 60 seconds, because in 1 minute there is 60 seconds, as you're doing that conversion, your units for seconds will cancel. 60 divided by 60 is still 1, so you'll have 1 minute. So now in this case, we have the unit of seconds in the bottom, and we're going to convert it because we want it now in minutes to be down here. Now we're saying there's 60 seconds in 1 minute. So when we do our conversion, again, our units per seconds will go away and you'll have 60 minutes. But again, whatever this number is here is the number that you're going to end up doing that numerical calculation. So, for example, if you had 60 seconds and you were converting it into a minute, the 60s would go away and you would have 1 minute in the denominator. So similar to here, where now we have in miles per second and we're trying to get in miles per minute. If we go back to our drawing board and do a quick thing. So if I have one, what was the units? Let me take a quick look. Mile per second. So 1 mile per second. Again, it's 1 mile in 1 second. And we're trying to get it to miles per minute. So I'm going to maintain my mile here. So, but I'm trying to get it into minutes. So again, in 1 minute, there is 60 seconds. So when I do this, my seconds symbol will go away. And I should be left with 1 times 60, which is 60, divided by 1 times 1, which is 1. But now carrying my units, that is in miles, and that is per minute. So that now I have 60 miles per minute, which should be equivalent to 1 mile per second. And if you think about it, it doesn't make sense. If you're going at 1 mile a second, then in 60 seconds, which is 1 minute, you should have traveled 60 miles. So it makes sense. So that's kind of the way that you go through the unit conversion process. It's a little bit more complicated. I get it when it's on the denominator than when it's in the numerator, but that's the process that you have to use in terms of thinking. So again, now that we know we have in miles per second and we're going to miles per minute, then that means that I should be multiplying this column here by 60, because again, there's 60 seconds in 1 minute. And now all that information is in miles per minute. So one more step to get into miles per hour. So we'll insert another column to our right, and this speed now should be in miles per hour, but I'm going to use the acronym MPH, miles per hour, MPH. And now, again, there's 60 minutes in 1 hour. So I'm taking again my miles per minute, multiplying by 60, because again, 60 minutes in 1 hour. And we finally have a number that should make more sense in terms of ground speed. So we've converted our altitude into feet for meters. Our speed, we've gone through the process of converting it from miles per second to feet per second, miles per second, then miles per minute, and finally miles per hour. And we don't have to convert course or altitude accuracy. Your latitude and longitude already in a format that we understand. And I'll show you what I mean with that, because we're going to plot it. Now, orientation, degrees, again, unit circle, 360 degrees. You should have an idea of what that is. We don't need to convert any of that. Angular velocity, it's in degrees per second. Again, should make sense of you're changing this much in terms of angle per second. be it from 0 to 90 in whatever time that span was. In terms of accelerations, again, that's the acceleration of gravitational force pulling you down. So if you think about it, your phone at the beginning of the runway was just kind of flat. Um, Again, look at that video of your orientation for your coordinate system, but in this case, Z is the one going up. So it's kind of me sitting down. The Z axis is going through my body, and I should be feeling the gravitational pull of Earth right now. And if you don't know it, it's about 9.81 meters per second squared. And again, you could ask Google. Gravitational acceleration. In feet per second, that's 32.17. In meters per second squared, it's about 9.81. So we're going to use that. And what I'm going to actually do here is I want to convert these into G's. So again, in your glider, you had an accelerometer dial, which basically tells you what the acceleration of gravity was as you were flying. So that is the Z axis on the dial. So I'm actually going to convert the Z into G's. So again, if going back similar to how we did for the distance and the time, here we're saying 1G. So I'm going to type in gravitational acceleration. I'll use accel for short. And this unit is we'll write it for meters per second squared. That number was 9.81 approximately. That's what Google said. And Google was right in this case. So now that we have that gravitational acceleration, we want to convert it into a Z acceleration, but in G's. So we know 1G is 9.81 in terms of when gravity is pulling you down. So if we were to take the Z measurement and divide it by 9.81, you will get a number that should be near 1 or identical to 1 when you're on the ground. And after that, the incremental numbers of by 1 should be, again, your sensation of feeling 1 time heavier than that if you end up going to 2Gs. So now we've converted your accelerations to a G. We'll ignore X and Y for now, but as a practice, go for it and convert those also to Gs. And now we finally have sensor information in units that make sense. Now, you might ask, well, what about time? Right? We know that these are incrementing in terms of 0.1 seconds. And if we were trying to compare it to the video of the GoPro camera, how do I make sure that I actually have all the information that I need to be able to do that correctly? Well, I would say let's create a time column with a hack when it starts at 0. Meaning, let's start with orientation. I'm going to insert a column to the right of that. And I'm just going to call it hack time. And I'm going to actually, for now, just do it in seconds. So what does that mean? If you were able to simultaneously click start on your GoPro camera and on your phone, it should be recording at the exact same starting point. So if at a specific time in your data, you want to go into your video to see what the gauges on the panel were for the glider, you should be able to synchronize that. Now, we started at 0 for 0 seconds, but then after that, it was an increment of 0.1 seconds because we were recording at 10 samples per second. Now, I'm not going to do this because it doesn't have what I want. I want this plus 0.01 and it's forcing me to do this format. So I need to actually change the format of this Excel column. So I just want it in plain number. There you go. Now I should be able to take this all the way down if I double click. Oh, it doesn't do like so. Maybe it does. Let's see. There we go. So now this is 0, 0.1, 0.2, 0.3, 0.4, 5, 6, 8, 9, 1 second. And again, that should make sense because you were collecting at 10 samples per second. And that's actually very interesting because we had, wow, I guess I had started the time exactly at 55 seconds when I clicked start that time. They might be off, right? Like here it just happens that each second is actually increasing around the same time. That's actually pretty cool. So now my time is in seconds. But what if I wanted it in seconds, minutes, and hours? We probably don't need it in hours. Your entire flight was probably just a couple minutes. So if you wanted a specific time, right? And for some reason you were looking at a number all the way down here and you're like, hey, what's 470 seconds dot one in terms of a time video? It's going to tell you usually in minutes and seconds. Well, we'll add another column. In this case, we'll actually add it to the left. So if this is hack time, and we'll say it's the seconds column, what is the hack time in minutes? Well, if you do hack time, and now for a minute, if you were to take this reading and if you recall, seconds to minute, 60 seconds and 1 minute divided by 60, you should know the minute for it. So if I take the seconds and I divide it by 60, because there's 60 seconds in 1 minute, and I'm going from seconds to minutes, then I should now be able to convert it where I should be able to get minutes. So 1 second, or actually even more better, 60 seconds should be 1 minute. So if I go down here to 60 seconds, here we go, is 1 minute. And if you look at the time, 11:38:39. In the beginning, it was 11:38. So again, it makes sense. Now, we finally have all the information you need to actually start plotting information, comparing it to the video, and get data out of your sensors. So in the next videos, I'll show you a quick way of how to plot a bunch of the 2D ones. You should know that. And if you don't, it's okay. I will show you how to do it in Google Sheets. But also, I will show you how to use an online free 3D plotter to get a 3D representation of your entire flight, so you can visualize how you're flying and at what altitude were you as you were in that specific location on Earth. So I hope you're able to follow along. If you need a little bit more time of doing those conversions, go back, re-watch the video. But in the next video, we'll start to make some plots. So until next time, take care and have fun.